Good morning. I am K. Palnivel, Assistant Professor of Mathematics, SNS College of Technology, Coimbatore. Today, I am going to the topic of case study on Lagrange interpolation by missing data solution of electricity consumption. Abstract. Missing data or values is common issue in processing a data set. The system utilizes and optimizes the electricity consumption data. Many problems occur when the data that are being sent by the sensor to the web server are missing due to the unstable internet connection. It is an essential matter since we want to capture the data by real time. The dataset are useful to learn and the pattern of the electricity consumption and predict the next electricity demand. Therefore, to overcome these problems, we try to propose a method to complete the missing data by applying Lagrange interpolating polynomial method. The missing data can be interpolated by using the first, second and third order of Lagrange interpolation and in determining the pattern data. Next, introduction. Missing data or values is a common issue in processing a data set. It is mostly that all instrumental time series are affected by missing values. There are two mainstream approaches in dealing with missing data. The first is by using only a subset of continuous records in a data set, and the next one is by ignoring the missing data based on an assumption that they may represent one continuous series. In case of deletion, any data with missing values is ignored from the data set, and standard methods for completing data are running on the remaining data cases. The presence of missing values in a dataset can affect the performance of a classify constructed using the dataset as a sample. Next one is missing data. Missing data is identically referred to a missing data mechanism, observation process or selection process. In context of missing data process, it is lead to missing data theory that has an impact on learning, inference and prediction. There are two fundamental categories of missing data: random and unrandom missing data. In case of random missing data, the process can be ignored and inference can be based only by the observed data. In this case, in many common generative models, the computing results are traceable. For the unrandom missing data, the missing one will be ignored. Lagrange interpolation. Interpolation is the process of finding the unknown values based on the known values. The Lagrange interpolating polynomial is simply a reformulation of the Newton polynomial that avoids the computation of divided differences. Intelligentsia is an information, communication and technology innovative solution that can control and monitor the energy consumption through the internet connection of web and mobile platforms. It can also adapt and learn the user consumption profile. Based on the related data, intelligentsia can produce intelligence flexible reporting. Implementation of Lagrange interpolation method. The Lagrange interpolation is the interpolation technique that using the polynomial restrictions. There are some record steps in this process. Voltage and current real-time data with the interval 30 seconds are captured by the sensor. Analyze and capture the data of voltage and current, whether they have a value above 0 or 0. If they are valued null, then it will be filled with y sign and the position of that y will be filled with x sign. After y is deducted, then the position of x will be become a base of capture. The data position that will be captured as followed, where the yellow highlight is represented the missing data. In determining the used Lagrange's order besides the data values, in the third case it may be used different Lagrange's order. For interpolating voltage can use the first order and the interpolating current value use the third order. In case of high number of data, the first order has appeared as the most frequent order. Based on the experiments and results, Lagrange's interpolation polynomial can be applied to overcome the missing data issues when the data is sending from sensor to the intelligentsia observer. The missing data can be interpolated by using the first order, second order and third order of Lagrange interpolation and in determining the pattern data. We applied BPSI technique, which is an improved technique of Lagrange's interpolating polynomial method, and emphasize more on the plot pattern data observation. This research then may support to predict the electricity consumption and to create an effective prediction model. For future research and accuracy, it is required to analyze the other methods that may suitable for intelligentsia missing data problems. Thank you for watching.